This week, we will be talking a lot about freshwater resources. And so, in addition to talking about rivers and streams, we will also spend some time thinking about lakes and lake ecosystems. The study of lakes is usually referred to limnology, although limnology can also have a much broader definition and can also refer to the study of any inland waters, including rivers, streams, ponds, and reservoirs. But mostly people use it to refer to the study of lakes. Limnology includes a lot of different factors, right? Because beyond there being water in a lake that animals live in, there are a lot of physical and chemical characteristics that help to create a specific and unique lake ecosystem. And so today we're going to spend some time talking about the physical system of a lake. We'll talk about the chemical characteristics of the water, and we'll also talk a little bit about the wide range of biology that can be found in lakes. It's also important to remember that on a geologic timescale, lakes are ephemeral. They will eventually dry out or fill in with sediment. They are not stable over long geologic time periods. In fact, lakes naturally only last on a scale of thousands to tens of thousands of years before they disappear. With human impact, this process can happen much more rapidly. And in fact, many lakes are changing, many lake ecosystems are changing rapidly. They're being filled in with sediment, they're drying out on a much more rapid timescale than you would find normally. And so that's why studying lakes is so important. So, lakes are intimately connected with human communities and have been for probably as long as humans have been around. In Ohio, we use lakes a lot for places where we pursue recreational activities. Um, and maybe some of your food comes from that if you do some fishing. But in countries throughout the world, lakes are used even more fully. So I do a lot of research and have done some field work in central peninsular India in the state of Maharashtra, and their water is a really important resource. And so you can see a couple of pictures from India, a woman washing her clothing in the lake water, women collecting water, and and also people fishing and catching fish in the lake water. And so people are really connected. And throughout the world, many lakes are still used for water, for cooking, for drinking, and for all of our other sort of domestic activities. And this is happening at a time when lakes and other freshwater resources are really impacted by human activities. There might be pollution in the lakes, either from industrial activities, from human wastewater, or from the introduction of extra fertilizer into the waters, which is called nutrient pollution. There can be human activities that increased silt and sediment going into the lakes. There can be invasive species that are introduced to the lakes. All of these things can really impact and disrupt the natural lake ecosystems. All right, so let's start with thinking about our lake ecosystems and how lakes form in the first place. So there are many different ways that lakes can form. Basins for lakes can form due to catastrophic events like the eruption of a volcano or tectonic rifting. And in the center is an example of that. That's a picture of Crater Lake National Park, which formed as a result of a volcanic eruption and creation of a crater. Um, Lakes can form by slower processes. Like on the left are pictures of kettle lakes. Kettle lakes are small, round lakes that are formed as glaciers are retreating and leave off a bit of ice that sinks into the sediment and creates a little divot. that then gets filled with water. So those are usually kind of small but very deep, very steep-sided lakes. Lakes can also occur when an area like a stream or a river becomes dammed. So on the picture on the right, you see a lake formed by a beaver dam, which is a natural form of damming. But damming can also happen as there are landslides or lava flows. And now we have many lakes that are formed by humans who have created dams on the landscape. Lakes can also form by changes in channels of rivers, oxbow lakes, which I talked about in the other lecture on rivers, um, and really like anything in the landscape that can cause water to accumulate in a divot can cause a lake. Um, there's a picture of the Great Lakes, which we are really familiar with here in Ohio, um, because they're formed by glacier processes. And then on the right is another picture of a glacial lake, except a high mountain glacier lake formed by melting glaciers into a, a recess in the rocks. Um, so really, there's all kinds of processes. What is interesting to note, or something to note and remember, is that the process that formed the lake has a big impact on the overall shape of the lake. So, for example, we'll go back to the slide. These kettle lakes are often small but deep and have steep sides. That's really common for a glacially caused lake. On the other hand, a lake caused by damming, like this beaver lake here on the right, often can be really large lakes, have a very extensive area, but they're normally not as deep. And that the profile of the lake, how deep it is or how wide it is, can really have an impact on other physical characters of the lake, like how stratified the lake can become. So one thing that can happen, especially in deeper lakes, is stratification of the water. And this usually is best developed during the summer months when the sun is heating the upper several feet of the water. The top of the lake becomes really warm and less dense, which prevents mixing with this deeper water, which remains colder and denser. And so you have this area where it's called a thermocline, where the temperature changes really rapidly, and there's not mixing between these upper and lower levels. So the upper layer of the lake kind of creates a lid on the top of the lake that restricts the availability of oxygen down to the deeper part of the lake. And so, what can happen during summer months when this thermocline is the most dramatic is that this area can become anoxic, which means that there's low oxygen in it. And this can especially happen when there's lots of productivity in the lake, when there's lots of biological activity up here, and then that algae or zooplankton or whatever is living up here dies, falls to the bottom of the lake, and then begins to decay. And that decay process uses up oxygen. And so it can rapidly use up the oxygen at the bottom of the lake. If this happens in lakes, that can often limit the types of fish that can live in the lake. If there's low oxygen or no oxygen at the bottom of the lake, you're not going to have cold water fishes living in the lake. Most of the fish will live up here in that warmer water. As I said before, this is a pretty seasonal event. So usually the thermocline or the difference between sort of the hot and the cold water will develop in the summer. And you may have experienced that if you have gone swimming in Ohio lakes during the summertime. The first couple of feet up here will be pretty nice and warm. But once you dive down several feet, you can go through this thermocline, and it can get pretty cold underneath it in the deep water. This happens a lot in deeper lakes, or I go diving sometimes in a quarry, right? And so that deep quarry water stays really cold all summer. Um, In the fall, when this temperature difference is, when there's less temperature difference between the surface and the deep waters, you can get turning over, right? So mixing here of that water to relieve that oxygen deficiency in the deeper water. This is encouraged by storms or wind that can occur more in the fall than in the summer. During the winter, you can have a cold layer developed at the surface where you might even freeze. And so in the winter, this gets sort of reversed where the colder water is on the surface and the deep water stays about the same temperature. And then in the spring, you can begin to warm it up again, moving towards that thermocline again in the summer. So you can get a lot of mixing in the fall and in the spring. In the summer, less mixing. In the winter, less mixing. All right, so those are some of the physical characters that impact lake functioning. I also want to talk a little bit about the chemistry of the lakes. And one of the most important things that we think about when we think about lake chemistry is the amount of nutrients that are in the lake. So we particularly, or people who study lakes, particularly focus on the nutrients phosphorus and nitrogen because these are relatively rare nutrients in the environment, and so they're often referred to as limiting nutrients. What that means practically is that if you just add a little bit of either of those nutrients, you can have a really large impact on the lakes and their ecosystems. Eutrophication is a term that is used to refer to adding either of those nutrients, as well as the sediment transport into a lake that's often associated with the addition of nutrients. And so it's important for us to remember and think about the impact that human activities have to add nutrients to the lake water and which can result in a really rapid change and shift in the ecosystems. When limnologists think about the amount of nutrients in a lake, they often refer to something called that they call the trophic status, which is measured by the amount of biomass, which is often measured by chlorophyll. So just seeing how much green is in the water and how much algae is there. And there's a couple other ways we're going to talk about Secchi depth in a minute, or you can just go ahead and measure the amount of phosphorus in general. But basically, the trophic state can be divided up into a couple groups. An oligotrophic state is a state where there's low nutrients and low algal biomass. And then it can range up to usually naturally a eutrophic state where there's high nutrient and high biomass. And in some cases, especially where there has been nutrient pollution, you can move into something called a hypereutrophic state where there's an excessive amount of nutrients and biomass in those lakes. So if you, this is a recent map that has been created using remote sensing to measure the amount of chlorophyll in lakes, which you can do from color on satellite images. And what you can see here is this is the abundance of eutrophic lakes, essentially. And so you can see that especially in the US Midwestern states, most of the lakes are falling into that eutrophic state. Um, and in contrast, you can see really low oligotrophic or low nutrient lakes in the Midwest. You can see that there are higher abundances of mixotrophic or low 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 nutrient lakes in these regions where there's less agriculture, sort of northern Midwest, northern Minnesota, Wisconsin, Michigan areas, the mountain, Montana, Idaho, sort of northern California. Um, but in areas where there's farming, you're going to get more eutrophic lakes, and we can think about that a little bit more as we walk through the Breakpoint book as well. All right, so one of the other ways that you can measure the trophic state is really just by measuring the how far light can penetrate into the water. And so one way that limnologists do that is by using something called a Secchi disk, which is just a disk with these black and white squares on it. You lower it into the water, until you can no longer see or distinguish between the black and white. Um, and then you figure out how far down the Secchi disk has gone before you can't see it anymore. And this is going to be really impacted by the amount of algae or biomass, tiny microscopic plants living in the water. So if you have more of those, if your water is more murky or green, you're going to have a smaller Secchi disk measurement than if you have really clear water. So this, just to give you an example, I was up on Lake Erie this summer and we did some Secchi disk measurements, and the Secchi disk did not go down very far, maybe 30, maybe 40 centimeters, before you couldn't distinguish between the black and the white anymore in the water. The water had so much stuff in it. And this is used to measure the trophic state and the amount of algae, but also to think about the depth of usable light penetration, which is usually about 2 times the Secchi depth. So if we think about that Lake Erie example, if the Secchi depth was 40 centimeters, it means that light is only penetrating into that water about 80 centimeters for things to photosynthesize. So basically, beyond a meter depth, there's not really much usable light penetrating into the lake. So this is just one way that the algal biomass can impact the overall lake ecosystem by changing the transparency of the lake water. So, lake chemistry, another part of lake chemistry is thinking about the hardness or the softness of the water. So, when limnologists talk about hard water, they're usually talking about water that has more dissolved elements in it, so more dissolved things. And soft water normally has less stuff dissolved in the water, fewer elements, fewer ions dissolved in it. And this is usually related to the bedrock, right? So the physical environment of the rock that's in the lake basin itself, that the lake basin is made into, or in the catchment of the lake. So generally, harder waters will usually develop in areas where there's lots of sedimentary rocks, so like limestones or sandstones that dissolve a little bit more easily, and and therefore, because they're dissolving easily, they're adding more materials, more dissolved elements to that water. Softer water generally occurs in areas where there's lots of hard rocks, which are, granites or metamorphic rocks that dissolve really slowly, that weather slowly, and so they're contributing less to the water. So the hardness or softness of the lake, like is as I just said, is immediately impacted by the rocks, like immediately surrounding that lake water that the lake water is sitting in, but also are impacted by the rocks in the catchment. And so I just wanted to show a picture to illustrate what I mean by a catchment of a lake. So this is really just the whole area where water is draining into that lake. So here's a map of the catchment area for some of the Great Lakes. Here is a more local example of some local reservoirs, and you can see the catchment area for them is quite large. The catchment area of a lake will really depend on just how the lake is physically situated in its environment. So, for example, a lake on a crater, like high up in a mountain, will usually have a very small catchment area because it's just like the surrounding high areas that drain into that lake. Whereas a lake that is more like a reservoir might have a really large catchment area because all of the lakes and streams that are running into that reservoir will shunt anything from that watershed or that catchment into the lake. So if we're thinking about what's happening in a lake, we really need to also consider what's happening in the catchment area. That can be naturally chemistry or thinking about pollutants that might be entering the lakes. Right. So our water chemistry that we were just talking about can have a really large influence on the biology of the lake. So for example, many of the algae living in lakes are something called diatoms, which are a microscopic algae that creates a silica shell that they live in, or a test. And that is made up of silica. So if there has to be dissolved silica in that lake water for diatoms to grow. Um, Another example would be the growth of mussels or snails that require calcium carbonate to make their shells. And so, once again, they would require the presence of calcium to be dissolved in the water in order for them to live and grow there. And so the chemistry can really have a large impact on things that are actually living in the lakes themselves. In addition, the hardness or softness of the water might indicate how, or might influence how lakes respond to pollutants or other foreign things coming into them. So, for example, hard water lakes generally are able to regulate themselves a little bit better when there's acid rain than soft water lakes. So soft water lakes might be more susceptible to acidification due to acid rain in their catchment area. All right, so I'm gonna close out by thinking about the biology of the lake. So what is actually living in the lakes? And there's a lot, so I'm not gonna like talk about every little single thing that lives in the lakes. But we can start with the base of the food chain in lakes, which are our microscopic photosynthesizers. These can include things like diatoms that I just talked about, or cyanobacteria, but generally they are microscopic algae that are photosynthesizing to produce energy. And so they act as the base of the food chain in many of the lakes. So they are the grass of the lakes. They're the primary producers. And it's great. Like we need those algae to live in the lakes. But sometimes the algae can kind of take over, especially if the lakes have become eutrophied or had excessive nutrients added to them. And sometimes that can be bad. So there are types of algae that are actually toxic or harmful to humans and other mammals. In large quantities. And one of those top culprits is this guy down here in the right-hand center of the screen, which is called microcystin. So if you live near Lake Erie, you might have heard of microcystin before. Microcystin is a cyanobacteria that can have large blooms in Lake Erie during the summer if there's warm conditions, if there's lots of nutrients in the water. And microcystin is toxic. If you've heard of people's dogs dying because they drank lake water, or of people getting sick from drinking lake water, a lot of times that is microcystin. And lakes in Ohio test for microcystin, and so a lot of times if you see a sign saying, it's not safe to swim, it's because there's a high microcystin content in that lake. Right. So what else lives in lakes? So there are macrophytes, which are the plants that live in lakes, like cattails or lily pads. Usually those live in the littoral zone, so that around the edge of the lake. There are also lots of zooplankton, so tiny microscopic animals living in the lakes that are munching on the microscopic algae and then becoming food for larger things themselves. So if we move up the food chain, right, there's going to be microinvertebrates, lots of larvae of insects like mayflies, mosquito larvae, dragonfly larvae. So lots of larvae, insect larvae live in water in the lakes. There's also going to be larger invertebrates that you can see, like mussels, other sorts of freshwater bivalves, snails, crawfish. And then if you move up the food chain, you're going to get your macrovertebrates, like fish. You can have amphibians, lizards, reptiles, I mean, like snakes, and birds as well, right? So there's lots of things that live in lakes. They're very complex food webs. Right. So just closing by reinforcing this area that lakes are critical habitat for wildlife. They have unique ecosystems, and they're really important freshwater resources for people throughout the world. And so we live next to lakes, we live on lakes, we use lakes. And it's really important for us to understand these ecosystems so that we can develop eco-friendly, sustainable ways that people can interact and use lakes so that we don't use these valuable freshwater resources, especially at a time when there's so many people living on the globe, so many people need access to clean fresh water.